Well, hello, welcome to the first video of this series that I'm going to call like resolving every single LeetCode problem that there is, maybe like a little bit of clickbait there. Every single 3,973 LeetCode problems that there is. Of course, I don't think that I'm going to be able to solve them all. That should require like a handful amount of hours that I don't have to resolve it because I have a family and I'm studying and I have to work too. So we're going to do this on our free time. As you may see, I already resolved some of the problems here, and we're going to resolve them all in C. We're not going to use any AI whatsoever. We're going to use online resources like the classic CPP reference and Geeks for Geeks, maybe Stack Overflow, and we're going to use Draw.io for drawing some things, right? Well, let me give you like a background. I started to learn in C basically by using this book that is called Data Structures in C, and it was written by these guys. Tannenbaum, Langsam, and Augustine. I hope that you can see them quite well. There you go. You can pause the video. And here it's basically every single data structure that there is. It has stacks, it has recursion, it has recursion is a method of resolving problems, not a data structure per se. It has queues, linked list, trees. It has algorithm like search and sorting, and graph, and also memory management. I haven't finished it yet. I'm still learning about trees, and I'm still like not through the whole book. But I recommend you to read it because it's really good. I know that there is a version in English that you might read in order for you to know what data structure are, and what data structure is, and it's going to help you a lot to resolve most of these LeetCode problems. I don't care about, because I know that people use LeetCode problems to prepare for interviews. I don't give a shit about preparing myself for interviews. I just want to know how things work on the background, and be better at solving problems or problem solving. So let's go ahead with the first one. There is two-sum. Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to the target. You might assume that each input will have exactly one solution, and you might not use the same element twice. You can return the answer in any order. So example 1 is going to give you an array 2, 7, 11, and 15, target 9, and the output must be 0 and 1. Let's try and dissect this here. I don't know if I can place like some text here. Text. Okay. Okay, we have our things here, right? So let's give it a try to see um, what that this actually means. So let's suppose that we have for array. Well, if you're in Python, you probably don't know. If you're a Python programmer and you're starting to know about Python and programming in general, you're not going to know what an array is, because in Python, you can do stupid shit. You can do like something like this, and I don't know. You can do stuff like this in Python, and it's not going to be an issue with that. You can call every single one of these things as with the index, as it's not going to give you a compiler error. It's not going to give you an error on the console or anything. You just don't know. You can get away with basically war crimes in Python, and C is more like restrict, and it's like black magic. You have to be very specific with the things that you're going to do, especially when you're going to deal with data structures. So, uh, in computers, you start counting up since on zero. I mean, if you have this, I don't know, these five spaces here, the computer is not going to start with one, two, three, four, and five. It's actually going to start up in zero. So if you want to call the first element of an array, you're going to do basically this nums, and then these braces, and then 0. And you want to call the second one, or the third one, or the fourth one, you're going to like subtract 1 from the actual place. For example, if you want to get third, you're going to do 3 minus 1, and that's going to be 2. So it's going to be nums braces 2, and it's going to give you this place over here, right? So that's like going to give you a heads up of what we're dealing with here, and why is 0 and 1 the output. Because 0 it's 2, and 1 it's 7, and 2 plus 7 equals 9, and that's the target. And what we have to do here is actually figure out a way of comparing every single element of the array, add them up, and then figure out if they are equal to the target. The way we do that is with a for loop inside another for loop, and then we're going to compare it with an if statement. So the first for loop is going to start in 0, and the second one is going to start in 0 plus 1, that's going to be equal to 1. But it's not going to be equal to 1 because then we're not going to reach out the end of the list as properly as we should. It's going to give you an error, and we're going to see it after this. But where we're basically going here is that we're going to compare. Let's like do it again over here. We're going to compare first the first with the second one, and then the first with the third, and the first with the fourth. Then we need to compare the second. I mean, we have to keep moving and compare when we're going to reach out the target. Then we compare the second to the third, and the second to the fourth, and then we have to keep moving. We have to compare then the third and the fourth until we reach the end. This is the end, the third, like the third iteration here, and that's why you have to like do 2 for loops, and then an if statement to compare if those are equal. Okay, well, let's see what, and then we now can start with the stopwatch. Here we see that it gives you these 4 parameters. It gives you the list. This is the list. This is the size of the list. Arrays, and this is the target, and this is the return size. You might see that this is an asterisk, and this is because that's a pointer, and a pointer is just basically a variable that is storing the memory address of another variable, and the other variable is actually storing the value. So we have to first derefer the pointer, and that's going to be just casted return size equals 2. Why 2? Because 2 is the amount of element that you're going to need in order to create the output. This is 1 and this is 2. Okay, and then we have to malloc the array, and that's called dynamic or like dynamic array. What is a dynamic and a static array? Well, static is when you do something like this. You have to create the data type that you're going to create with the array, and then you have to create the name and how many spaces that's going to have, and then you have to like go and basically create the fixed result for the thing. Okay, well, this is static, and this is what you call static array in C. When you want to create when you don't want to like create the elements by yourself, and you want to dynamically add the numbers or like the elements to the array, you have to try and ask nicely to the memory of your program for some space, so you can then add up the elements to that space. And since it's an array, those spaces has to be contiguous. One has to be one after the other. So the way you do that is that you have to create, since we're dealing with memory, you have to create a pointer variable that is going to have integers, and it's going to ask for the memory a certain amount of bytes. How many bytes? Well, it's going to be return size times size of integer. And this is the same because we know that this is 2. This is the same as saying 2 times 4 equals 8 bytes. Okay, when we want to create a dynamic array, you have to ask for the amount of bytes that you want to preserve or you want to have within your dynamic created array. So size of int is because an integer, the data type integer, needs to have or uses 4 bytes to storage itself. And since we want to have 2 elements, it's going to be 4 times 2 and it's going to be 8. And then we have to program the second like the second part of the solution that's going to be like this part, the annotated for loop. And that's going to be, I don't know if it's called annotated or not. In Spanish it's called anillado, but I don't know. It's going to be, this is the way that you create the for loop, by the way, in C. It's going to be I'm sorry, no. You have to specify data types in C. Oh shit. So it's going to be something like this. Okay, so this is where we're going to start. This is where we're going to finish, and this it's every time that it goes around, it's going to add up one number. This is the end because this is the num size. And what I told you before is that every single array is basically n times minus 1. What we're doing here is, for index, this is for index. What we're doing here is that we're starting on index 1, on index 0. We're going to end up in the index n minus 1. And why minus 1? Because this is not less or equal. This is just less. It's not taking the number itself. It's just going to stop on the number before. And the number before is going to be the number before minus 1, and we're going to end up right there. So we have to create the second one that's going to be the second for that's going to be integer of j. And we're going to try something here. We're going to place like 0. I'm sorry, in 1. Then we're going to create the same thing here. Okay, now we have to make the comparisons. Is this number plus this number equal to the target? Well, the way you do that is like this. I took the liberty of looking it up on TPP reference because I don't recall exactly how it is, but it's if expression and then to return. So that's going to be if this number plus this number equals this number, then we're going to add the index of that number on our list. So it's going to be result index 0. It's going to be this one, and the result of this one is going to be equals j. So the first index is going to be I, and the second index is going to be j. If this comes true, we can't just close up the whole for loop. So we can do that by just no, this will be here. We can do that by creating a return here, and this is going to actually close up the for all of them. And before we finish up with the function, we also have to call it again. So this should be it for the problem. Expected expression before int. How does it was again? Expected expression before int. Int result. Expected expression before int. Oh, okay. It's not. Yeah, it's like this. the asterisk goes in the front. Okay, we can see that three of them cases are solved. But if we go with submissions and then we see it's not going to be enough for all the possible test cases to pass it up, because when you see this place, you see that it's actually storing 5 and 5. So 5 plus 5 is equal 10, but it's not going through this. I mean, it's not going to the second one to actually. I mean, it's not going to the third index to compare it. It's just staying here. So the way we resolve that is actually going, not starting in one. Is actually iterating. Thinking of what number are we in right now. So if we are in the second one, we want to be on the third one on the second iteration of the loop, and the way we do that is like this. If we are on a certain location, we want to be on the right. I mean, on the next upcoming location. So that should solve the problem of like everything basically. We see that the runtime was 99 milliseconds. It beats up 80% of everyone, and the memory could be better. I don't know how to how to manage memory yet, but that's the way we can do it, right? So I hope that you learn how to resolve the two-sum problem. Again, if we go like this, when it's going to the second one, it's actually going to stop there and not going to add anything. Let's go and try it up again, because I expect that every single one of the test cases it's going to be placed here. I mean, all of the possible solutions are going to be here because it's starting in one. All of these test cases, since they were not equal, you just started on the next one. But when it's going to the first index on the first iteration and then starting one, it's just comparing 1 to 1, and that's not good at all. I should be going through every single iteration, because here it's like when it goes to the first round, okay, it's 1 and then it goes back, and then here is add up 1, so it's 1 comparing to 1, and that's not good, because it's like giving you this error. And I guess that every single one of the rest of the test cases are just going through the same problem. That's comparing the second index to the second index, right? So the first we solved that is just add up 1, man. Just when we're here, we want to compare to the next one, as I said previously, right? Compare with the next available element. Well, that's it for this issue. It was pretty simple. It's the first problem of going to submit it. I'm also going to submit this on GitHub, so you're going to be having the option of give it a look on GitHub. But yes, it wasn't too hard. It's actually a pretty simple problem that if you look for some documentation, you're going to find a lot of answers, and you're going to figure out that it's not hard at all. You have to be very careful with syntax, especially if you're coming from like Python or any other languages, because C is very strict. Well, that's it. See you on the next problem. That's going to be add two numbers.